Now this problem is related to combining equilibrium expressions. So let us try yourself. So we have to determine equilibrium constant, that is Kc value, for this reaction. To solve this problem, we must have some background of equilibrium expression, how equilibrium expression changes, that is there are some rules. And first rule is law of reciprocal. And this rule says, let us say if I have A plus B, this gives you C plus D. And if I reverse the reaction, let us say equilibrium constant for this reaction is K. And if I reverse the reaction C plus D, and this gives you A plus B, in that case new equilibrium constant K dash will be reciprocal of original equilibrium constant. And this is called law of reciprocal. That is, if you reverse the reaction, equilibrium constant will be reciprocal. Now next rule we have, that is law of product. And what this law says, let us say we have A plus B, this gives you C, and D plus E gives you F. Equilibrium constant for this reaction is K1 and equilibrium constant for this reaction is K2. And now if I sum these two reaction, I will have A plus B plus D plus E, and now this will give you C plus F. Then equilibrium constant for equivalent reaction or overall reaction is K1 into K2. So what is this rule? That is, if we sum the reaction, equilibrium constant of overall reaction will be multiplied. So that is, if we sum the reaction, equilibrium constant gets multiplied. Now third rule, and that is basically called law of power. And what is this rule? Let us say if I have A gives you B plus C, equilibrium constant for this reaction is K, and now if we multiply this equilibrium expression by N, so everywhere I have to write equilibrium because these are equilibrium expressions. Now if I multiply this equation by N both sides, so I will have NB plus NC, and now let us say equilibrium constant, new equilibrium constant is K dash. So this law says new equilibrium constant will be K to the power N. That is, if I multiply by a coefficient N to the equilibrium expression, new equilibrium constant will be raised to the power same coefficient, that is N. So meaning is, if we multiply equilibrium expression by N, equilibrium constant will be raised to the power N. Now we'll use these three rules to solve this problem. We have been given HF, H plus, F minus, Kc is given. So let us call this is reaction 1 and this is reaction 2. We have to find equilibrium constant for this reaction. One thing is clear, I have 2 HF. This means I have to multiply the first equation by 2. So if I multiply by 2 and then I can use the law of power, then the equilibrium constant will also be a squared. So we have HF, and this gives you H plus F minus, and equilibrium constant for this reaction is given 6.8 into 10 to the power minus 4. Now if we multiply by 2 both sides, here we will have equilibrium constant, new equilibrium constant Kc dash will be a squared, that is 6.8 into 10 to the power minus 4 raised to the power 2, that is the power will be same as the coefficient. Now let us see the next part. We have C2O4 2 minus, but in this equation C2O4 minus is right side, but in this equation this is left side. This suggests we have to reverse this equation. That is, it is given H2C2O4 and this gives you 2H plus C2O4 2 minus, and equilibrium constant for this reaction is given Kc is 3.8 into 10 to the power minus 6. Now since I need this C2O4 2 minus left side, we have to reverse this reaction. That is, if I do reverse, 2H plus C2O4 2 minus, this will give you H2C2O4. Now if I reverse this equation, equilibrium constant, now let us say this is Kc double dash, also gets reciprocal, that is 1 by Kc, and that is 1 by 3.8 into 10 to the power minus 6. Now let us call this equation as equation number 1 and call this as equation number 2. Now let us write these two equations. So we have equation 1 and equilibrium constant for this reaction is 6.8 into 10 to the power minus 4 raised to the power 2, and for this reaction we have 2H plus C2O4 2 minus, equilibrium constant for this reaction is given, that is Kc double dash, and this is 1 by 3.8 into 10 to the power minus 6. Now we can get the overall equation, this one. We can get the overall equation if we basically sum these two equations. So let us sum these two equations. If I sum these two equations, we have 2HF plus C2O4 2 minus, and this will give you F minus plus H2C2O4. Basically this should be 2F minus. I have to have, because I have multiplied by 2, so there should be a 2 here. So this is 2F minus, that is H2C2O4. Now check overall equation. This equation is same as this one. Here you have 2HF C2O4 2 minus 2F minus H2C2O4, and these all are basically in solution, that is in aqueous phase. Now if we sum this reaction, overall equilibrium constant gets multiplied. So if we sum equilibrium expressions, equilibrium constant gets multiplied, so we will have 6.8 into 10 to the power minus 4 raised to the power 2 divided by 3.8 into 10 to the power minus 6. So we have to solve this value, that is Kc double dash is 6.8 raised to the power 2 into 10 to the power minus 8, and this divided by 3.8 into 10 to the power minus 6. So this is 6.8 raised to the power 2 divided by 3.8 into 10 to the power minus 2. So we can use calculator. 6.8 into 6.8, and this divided by 3.8. So this is 12.16. Or we can write Kc double dash, that is 1.216 into 10 to the power minus 1. So this is the overall equilibrium constant. So overall equilibrium constant, and this is equals to 1.216 into 10 to the power minus 1, or we can write 0.1216. Now let us do a practice exercise. Here we have this one. Same concept you have to apply. Try yourself. So basically you have to find Kp for this reaction, and Kp for these two reactions is given. So you have been given Kp for H2 plus I2, that is 2Hi. This is Kp is given 1.04 into 10 to the power minus 4. We have been also given Kp for this reaction, N2 plus 3H2, two NH3, and the Kp value is this. Okay, so this value is 54. So the above value is, so this value is Kp for this reaction is 54, and Kp for this reaction is 1.04 into 10 to the power minus 4. And now we have to find Kp for this reaction 2NH3 plus 3I2, and this gives you 6Hi plus N2. Now you see we have to manipulate this one. If you see the second reaction, I have right side 2NH3. So basically I have to reverse the second reaction. So if I reverse, let us call this is 1, this is 2. So if I reverse the second reaction, so second reaction if I reverse, I will have 2NH3, and this will give you N2 plus 3H2. If I reverse the reaction equilibrium expression, equilibrium constant gets reversed because basically gets reciprocal. So I will have 1.04 into 10 to the power minus 4. Now if you see this equation, I have 3I2. So this means I have to multiply equation 1 by 3. So multiply equation 1 by 3. So if I multiply by 3, so I will have 3H2 plus 3I2, and this will give you 6Hi. Now equilibrium constant will be raised to the power same coefficient, so we have multiplied by 3. So equilibrium constant will have a power of 3. And now basically we can sum these two reactions to get the overall reaction. So 3H2 basically cancels, so we have 2NH3 plus 3I2, and this will give you N2 plus 6Hi. So if we sum the equilibrium expression, equilibrium constant gets multiplied, so Kp triple dash is equals to 54 raised to the power 3, and this divided by 1.04 into 10 to the power minus 4. So we can write equilibrium constant for this reaction, that is 54 raised to the power 3, 1.04 into 10 to the power 4. So we can use calculator. 54 multiplied by 54 and this divided by 1.04. So this is around 151.4 into 10 to the power 3. So I will have 151 into 10 to the power 3 into 10 to the power 4. So this will come out to be 151 into 10 to the power 7. Or I can write in scientific notation 1.51 into 10 to the power 9. So equilibrium constant for this reaction, that is the overall reaction, is very high. That is overall reaction has equilibrium constant value, and this is equals to 1.51 into 10 to the power 9. So this means product is favored. So nitrogen and HI favored. So equilibrium constant is very high. So mainly product is favored.